All right, guys, let's go right into it. Vectors 3. We might have to do one more video, like a touch-up for an activity that we're going to be doing pretty soon. But let's get right into it, and here we go. So it says, given the standard unit vector I and j, copy these vectors in order to create the resultant vector -3, 5. So remember in notes 1, or vectors 1, I was a vector in the x direction, and j was a vector in the y direction. So that's why you see 0, 1, and 1, 0. And in case you're wondering why the 1, because it's 1 unit. So what they're asking is that they want to see this resultant vector from these two. Well, the only way you're going to get a -3 is if you have a -3 times this vector here. So let's see, -3 times 1, 0, and then plus, let's see, the only way you're going to get a 5 is if you multiply the vector j by 5. So 5 times 0, 1. So notice when I do that, you get -3. And remember, this is just I, right? So -3i, oh, free birds, plus, and this is just j, plus 5j. And usually you have a little hat. And there it is, guys. You didn't have to do all that work. You could just look at this and like, oh, okay, x and y. So you could have just gone -3i plus 5j, and then you're done. But yeah, this is the work leading up to that. Let's see how it's going to look on Delta Math, guys. So let's do that real quick, and so you guys can see how that's going to look. Hey guys, here we go. So again, like we stated earlier, that -3, 5 is like saying -3i plus 5j. So since I need to go in the opposite direction, here it is. Here's my I vector and my j vector. The unit vector, unit just means 1, right? So I need to negate I because I need to go in the other direction. So negate I, and I need 3 of those going to the left. Well, I already got 1 there, I guess. So here's the second one, and then here's the third one. What you're going to be doing pretty much, if you're just messing with I and j, you're going to be making right triangles, guys, over and over again. So here we go. So now I need 5 of them going up. So where the I ended, you're going to continue with the j. 1, 2, 3, 4, 5. Hopefully there's not too much background noise, guys. I have the TV on at the moment. So there it is. And a nice right triangle, 3, 5, and then the resultant vector is whatever 3 squared plus 5 squared, and the square root of that is. So all right, so there we go. So now we're going to write it in ij form. So I'm just going to put -3 plus 5j. So this is the equivalent to this statement up here. Push try, and of course we're right, not I'm right. And then it says show numerically, which I guess -3 times your x movement, your I there, and then 5 times your j there. So you just multiply these by each one individually. So -3, 0. This indicates your -3i, and then 5 times 0 is 0, and then 5 times 1 is 5. That indicates your 5j, and then push try. This is correct. You may now press submit. So, I don't know why you got to press submit. You could have just done it right off the bat. But all right, that's fine. And there it is, guys. And that's what we're going to be doing over and over again, guys. All right, cool. Later, guys. Well, not later. We're going to continue. But all right, here we go. All right, so continuing, it says express the vector -6, -3. So there's your I component, there's your j component. In terms of the standard unit vectors I and j. So that's pretty basic, guys. We're just going to go, well, that's your x direction, so -6i plus -3j. If you want to take out that plus and just make it a minus, that's fine. -6i minus 3j. And there it is, that's it. All right, the next one, given vector u is 1, -1, and vector v is -4 plus, 1, determine the value of 2v minus 4u. All right, so let's figure out what the value of 2v is first. So 2v is nothing more than 2 times vector v, and vector v is -4, 1. So what I get is -8, 2. Let me correct my chevron there. All right, let's do 4u. And hopefully I'm not making any mistakes here. 4 times vector u. So 4 times 1, -1. And then that's going to be 4, -4. All right, so now finally the product, 2v. And I always like to do plus a negative, guys. Plus a -4u. Or I guess in this case, I don't really have to say plus and negative. But when you're doing graphing, and you'll see in a little bit what I mean, because I'm going to show you how it's going to look on Delta Math. When you're doing graphing, you always want to do plus and negative. So 2v is just this guy, so negative 8 comma 2, and then minus, and then 4v. Oh, I messed up, huh? Oh, no, I didn't. That was correct. How come you guys didn't tell me? Tell me that I was right. Minus 4u. So I'm going to subtract this vector here. 4 comma negative 4. All right, when I do that, negative 8 minus 4, that's a negative 12. And then 2 minus a negative, so that turns to a plus. 2 plus 4, that is a 6. So there it is. Negative 12 comma 6. Now let's go ahead and look how it's going to look in Delta Math. So here we go, guys. We have that same question now, but we're asked to graph this or to show it graphically. So again, when it comes to this, I like to go like 2v plus a negative 4u. So here's the v vector, here's the u vector, the ones that were already given here. So I'm going to do the 2v first. So here, that's 1v, and then here's 2v. And I'm going to add a negative 4u. So that u there, I'm going to go to negate u right here. And now look, it's negated. So now it's in the other direction, the opposite direction. That gives you the negative. And I'm going to do 4 of those. So I'm going to drag 1 right on top of that. 1, 2, 3, 4. It's easier if you have a mouse. And where does it terminate? So if you were to start your resultant vector right here, it would end where this last vector stops. And that looks like the value is negative 12, 6, which is what we got also without graphing or anything, guys. So negative 12, 6. And I'm going to click submit. I'm going to put yes. And they decided to do, it looks like they did the u's first and then they added the v's. That's fine. We got the same answer as you can see. So here's our graph, here's their graph. It's really the same as negative u's and 2v's adding up tail to tip. All right, whatever. I like mine better, but it's okay. There it is, guys. And hopefully you see that this is not that bad. It's pretty easy. And let's see if we can get this show on the road. All right, so now we start getting a little bit more interesting here. It says, given vector u is 4 comma negative 4 and v is negative 1 comma negative 2, find a linear combination of the vectors u and v that would result in the vector 1, negative 10. So what that means, guys, the linear combination means I have some number, and usually they go alphabetical order. I'll just say, look, like this. I have some number in front of this. I'm going to put a box plus some number in front of the v. I'm going to put a box in there. And I want, when I add these suckers up, when I add those vectors up, I want the resulting vector to be a 1 comma negative 10. So this one's pretty straightforward. I can see I have a 4 and I have a negative 1 in the x component or the I component. So if I were to make the v a 3, if I were to say 3 times v, that would be a 3. And then 4 minus 3, or negative 3, correction. 4 minus 3 would give you a 1. Correct? Yes. So now we got to check. Does it work for the y as well? Because it says negative 10 here. So let's see. Negative 4, let's see. I said I'm going to multiply this by 3, right? So 3 times negative 2 is negative 6. Negative 4 minus 6 is negative 10. Perfect. It works, guys. In case you're wondering, Chavez, I have no idea what you're doing. Here's what I'm doing. Vector u, just one of these u's, is just 4 comma negative 4. Vector v is negative 1 comma 2. But if I say 3v, notice I put 3 in the front of the v. That means 3 times vector negative 1 comma negative 2. And when I do that, here's the resultant vector that I get from 3 times v. Negative 3 comma negative 6. So if I take vector u, so here it is. If I take this vector and I go 4 comma negative 4, and I'm going to subtract, or I guess you can say add, if I add 3v, you'll get this vector, negative 3 comma negative 6. And if I add these, well, look, x component, 4 plus a negative 3 is 1. Negative 4 plus a negative 6, that is negative 10. So it worked out. So what did I need? I need 1 of these, and I need 3 of the v's. So 1 of the u's and 3 of the v's. So that's my linear combination. 1u, you don't have to say 1 there, plus 3v will give you the resultant vector 1 comma negative 10. So let's see how this looks on delta math, guys. So let's take care of that. All right, guys, here's that same question again. So vector u is given right here. It's that dashed line. Vector v is the smaller one here. Find the linear combination. Again, we just said it right now. So it looks like we need to go from here, and then somehow we need another vector from here that's going to touch the resultant arrowhead over here. So we said that we put, I believe we said we put 3 of these. So check it out. If I go bam, 1, and then another one, 2, and then 1 more. And look at that, perfect. So yeah, there it is. So how many U's? We did 1 U there. So 1 of those. And then how many V's? 1, 2, 3. So there it is. We push try. And then to show numerically why this is true, well, 1 times 4 times negative 4 is going to give you itself. 1 times anything is itself. And then 3 times negative 1 is negative 3. And then 3 times negative 2 is negative 6. And then when you add negative 4, negative 6, that is negative 10. And then 4 plus a negative 3, that is 1. So there it is. It says correct. And then we submit. And yay. Cool. Very cool, guys. All right, let's continue. All right, here we go. Okay, so that one was pretty easy. So now here's a tough one. So this is supposedly you guys talking, right? But Chavez, what if it's not? What if it isn't so obvious like the last one? All right, so here is one where it's not obvious. Given vector u and v, find a linear combination of u and v that would result in the vector negative 2, negative 6. All right, looking at it, I see the difference between 2 and 5 is 3, or I guess negative 3. If you say 2 minus 5, if you say 5 minus 2, that's 3. And obviously, that's not going to help me with that. So I have to think of how am I going to get, so focus on the x, not focus on your x. You don't want to focus on your x's, guys. Never focus on your x's. Focus on your I here, or your x component. And I want when I multiply and add these, I want to add up to a negative 2. So I see a 5 here, and I see a 2 here, and I'm thinking, okay, 5 times what number plus 2 times what number is going to give me a negative 2. So immediately I know that I want a negative output. I want the larger number to be negative. So I'm going to make this 5, I'm going to say I want to make that negative, and I'm going to say negative 2. So right now this is negative 10. Now, how do I get from negative 10 to negative 2? Well, I'm going to have to add 8 to it, guys. Well, look, I already have the number 2 here. So in order for me to get to 8, I'm just going to make this a 4. So 5 times negative 2 is negative 10, and then 2 times 4, that is 8. And if I add those, I will get negative 2. So now, so this is a magic number. Negative 2 and 4. I'm going to check. If these work. So I'm going to say, all right, the 5 was with the v. So I'm going to write negative 2v. And I guess I should go back to red, right? So negative 2v is going to be negative 2 times 5 comma negative 1. If you're wondering what I'm doing is I'm getting the magnitudes here, guys. So I'm going to say that is negative 10 comma positive 2. And then I need the 4u. So 4u is going to be 4 times 2 comma negative 2. So I get 8 comma negative 8. Oh, that's not an 8. Negative 8. All right, so let's see if this works. I'm going to add them together. So I'm going to write the 4u first. So I'm going to say 4u plus a negative 2v. And let's see if that works. 8 plus, okay, yeah, this is already, so let's not get confused. All this is already negative 2v, guys. So we're just going to have to add the negative 10. So 8 plus a negative 10, that is negative 2. And then negative 8 plus 2, that is negative 6. Yay, look at that. We got it. So we figured out. So the number is 4 and negative 2. And that's it, guys. And that's really about as hard as it gets. Hopefully, you enjoyed this video, guys. If you find any mistakes or errors, let me know. I hope I explained everything clearly. And that's it. So yeah, let's knock out those Delta Math activities, guys. And if you have any questions, let me know. And we'll have a Zoom tutoring session on Wednesday, so tomorrow. So all right, guys. Talk to you guys later. Bye. Oh, give it a thumbs up, please. Bye.